Hello and welcome to this course in Java programming. I'm your video presenter Colin Archibald. To start this course we're going to jump right in, and even in this first segment we're going to write a small Java program. It's assumed that you have some knowledge of programming concepts. So at Valencia that means you've taken COP 1006, but it might also mean that you have some programming in your background. So we're not going to spend a whole lot of time talking about what a variable is and what an if statement is. You're just going to have assumed to have some concepts. So the objective of this entire class is to make you knowledgeable and practiced in all of the significant aspects of the Java language up to and including object-oriented programming, inheritance, and polymorphism. We're going to use for this course the most current version of the Java Developers Kit. As of today that's 1.6 something, but when you go and get your JDK you would download the most recent one. They will be backwardly compatible and any of them will be fine for this course. We're going to use the Eclipse development environment. Both of these, the JDK and Eclipse, are available to anyone in the world at no charge. So you can download and install these on your PC. And I'm not going to take the time to show you how to do that in this segment. That's described in an appendix, A1. So scroll down until you find that appendix if you need to set up your machine with the Java Developers Kit and Eclipse. Let's talk about how to use these hands-on video presentations. Presumably you're in an online class or a hybrid class and you're using these instead of going to the classroom and sitting through the lectures and taking notes. So you have a big advantage. You don't have to leave your house. But that doesn't mean that you shouldn't be taking notes and watching them as if you were in the lecture room. So print out these slides. These are PowerPoint slides that are available to you, and if you print them so that you can take notes on the side, we've really watched this a lot of times. The students who do this, as opposed to watching these as if they were watching TV, have a much higher chance of success. So start off right from the beginning. Make a binder, print the PowerPoint slides, get ready to participate in the presentation. While you're watching the videos, have your Eclipse development environment open at the same time and flip back and forth. So once the concepts are demonstrated on the video, you might believe them, but you won't remember them unless you demonstrate them yourself in the development environment. So write code along with the video presentations. It's another one of the things we've observed as a key to success. So mix programming in with understanding the concepts. This is not optional. You really have to learn the art of problem solving. So learning the words in a language is quite different from learning to express something in a language. And it's the same in Java. Solving problems is a different skill from understanding the solution to a problem. So as I show you things, that will be different from starting from a problem statement and solving the problem yourself. You really should have a Java textbook to go along with this, and if you're in my class at Valencia, I will have required a Java textbook for the semester. Okay, I promised you that we would jump right in. So I want us to look at a Java program, and this is the smallest Java program that there is, and most of it looks cryptic. So this is the starting place for us. You don't know what a lot of this means, and that's okay. You don't know what public means yet. You don't know what class is. You don't know what static is, or void, or string, or these square brackets. But we have to have a starting place for learning, and this is how we're going to do it. We'll make this very small class that has a main method in it. So all you have to know for now is that the execution of your Java program will always start in the main method, and we'll write a small program that prints out hello universe onto the console, and that's an important milestone for us. We will have a Java program working and then we will be able to experiment inside of the main method for several of the upcoming segments. We can do all of our work just here inside of the main method. So let's go and do that in Eclipse. Let's write this small program, and it will be a good starting point to have something running. Okay, so here we are in the Eclipse environment, and we're going to make a project from scratch. So all Java programs in Eclipse have to exist in an Eclipse project. So let's do File, New, Project, and we will pick a Java project. You can give this project any name you want. I'll call mine 01 Hello. Maybe I can organize the projects by the segment number. And you don't need to do anything in the rest of this dialog. We can just say finish. And now on the left we have a Java project called 01 Hello. And if you open that up, you find that there's a source folder created for you. And in that source folder, we're going to make our Java program. So Eclipse is assuming that you're making a large, complicated program with lots of classes and ways to organize it, but we're only going to have one. But we'll start out by understanding that we organize our source code into folders, and Eclipse makes this source folder for us. So right-click on the source folder itself and say New, and this time we're going to make a class. So we'll put a class inside of that folder, and the name of this class will start with a capital letter, and it will create a file called hello.java, and it will put this class into that file. So here's the smallest possible class in the world. It starts with a capital letter, and it's in a file called hello.java. And now inside of this class we're going to make the main method. And remember, this one, you don't really know why it looks like this, but it's a public static void main, and it takes an array of strings which we won't use, and you can call them whatever you want. People usually call them args. And you might notice as we're typing, Eclipse will underline things with red squigglies and put red X's out at the side. So it's actually compiling the code as we type it, and it's looking for errors. You can't have just a capital S. Some people are annoyed by this because it's telling you you're making mistakes as you go along when you just haven't finished yet. So we're going to have a very small program that will do an output statement onto the console, and we'll say system.out.println println, and then something inside of double quotes here. You can put whatever you want. Okay, so all of the red squigglies have gone away, and there's lots of different ways to achieve the same thing within Eclipse. I tend to like to get students to right-click on things. It's very a good environment for context menus. So if you right-click on the source file and then say Run as a Java application. So we have run this program, and down here on the console window, this is the output from the program. Okay, so let's look at what we've done. We have a Java class that starts here and ends here, and inside the class we have a method, and it's the main method, and when we run the program, the main method is the one that executes. So we're going to do our demonstrations in, well, we'll learn the primitives of the language inside of the main method for the next several segments. So you have to have a main method that works, so that as we go along introducing all of the little parts, you can test them out inside of a working main method and see that your program runs. So let's go back to the slides now. This is an important milestone. If you didn't get a Java program to run, you need to do that. Go to the appendix, get your machine set up correctly, rewind this and follow the steps carefully until you get your Hello Universe program to run correctly. Okay, just to review what we saw in the Eclipse environment. The syntax errors, these are the rules for correct Java language code, are found at compile time, and Eclipse will indicate these while you're typing. It turns out to be a time saver. You won't type a lot of code and not know if it's correct syntax or not. As soon as you have a red squiggly, you should go and figure out what you've done wrong. The program output in our simple programs as we get started here is going to appear on a console window, and this is at the bottom of the same environment, so you can see the code and the output from running the code at the same time. The main method is the entry point of every Java application. So even though some of this is a little bit cryptic, the public static void main, you have to have this to get started. If you didn't get a Java program to run, you need to go and do that. So if you need to set up your equipment, your computer, to get Java running, you can check out Appendix A1 where that's described. Okay, we're going to change gears a little bit here. There's a lot of words on this slide, but it's mostly a story. So it's important for us to have some concept of why we're learning the Java language. Where did it come from? Why is it a good thing? So let's talk about the language and its history first of all. It was created by a man named James Gosling at Sun Microsystems, and previously he was working on a language called Oak, and the objective of Oak was to program small devices that had various hardware. And the difficulty is, if you write programs in an old-fashioned language like C, you would be writing the code to run on a specific hardware. That would mean that you couldn't reuse that exact code to go and program a different device. Well, Gosling didn't like this, so he created a platform-independent language, and that means that the code, instead of running on a piece of hardware, it will run on a piece of software. And his objective was to program small devices like cell phones and PDAs and so on, and they canceled the entire project. And something happened then that was quite unexpected. In the early 90s, the internet became very popular, and computers started going into people's homes that had internet access. So what we needed then was a language that could run on any computer that was browsing the internet. So if you're sitting there browsing the internet on a Mac, someone could send you some code from their web server that would execute on your Mac. Or someone who was working on a PC, browsing the internet on a PC, they could send you some code that would execute on the PC. And there was no existing language for doing that, a platform-independent or a hardware-independent language. So the Oak project at Sun that had been cancelled was revived, and they called it Java, apparently because they were in a coffee shop at the time. And it was 1995 when Java 1.0 was released. This is the first version of Java that was publicly released. And early Java code, given the motivation for having this new language, it shouldn't be surprising that early Java code was written as applets. And applets, they're still around. They are small programs that run in the context of a web browser. They're not nearly as popular as they used to be. There are other ways of doing this now, of sending code across the internet to get executed on the client machine. So Java didn't go away when applets lost their popularity. People started using Java to write applications, which are programs that run on a machine, like any other program, like Microsoft Word or any program that you run on a machine. And this made Java a competitor of general-purpose computer languages, especially C++. And more recently, Java has also become popular for writing code that executes on web servers. So web server applications, or so-called web apps. and also for programs that run on cell phones and PDAs. So we've come back to the original purpose of what Gosling was trying to do. Okay, so there's a little bit of history, and let's talk about why Java. Why does it work? Is it a language that we should be learning right now? And there are a few reasons. The first one we talked about on the previous slide, the reason that it came into existence, and platform independence. And let's think about what that means. We wrote a small program called hello.java. That's a text file where we put our Java code, and when it got compiled, it made this file, hello.class. And in old languages, we would have an executable that would run on a piece of hardware. But in Java's case, we have an executable that runs on a piece of software. So every machine practically in the world, every PC and Mac will have a Java virtual machine. You can write these virtual machines, they're pieces of software, according to the specification that are provided by Sun, so that this piece of code will execute the same on a PC as it will on a Mac, as it will on an AS400, or a Linux box, or any kind of a machine that has a valid Java virtual machine. So this part, the virtual machine, is not platform independent. It's the code that you write that executes on the virtual machine. This is where the platform independence part comes from. And the motto of Java when it first came out was write once, run anywhere, which is very attractive for people who are trying to write software that can be marketed to the widest possible audience. So if you want to sell your software to people who have Macs or AS400s or PCs or old IBM machines of any kind, this was a very attractive option, and it was the only one in the world when it first came out. What else is good about Java? Well, it's object-oriented. You may or may not know what that means at this point. It's free. Anyone in the world can download the JDK and write Java code. Presumably everyone in the class has already done that. And this is a big question of why is it successful. Very early on, Oracle made a decision to use Java in its company to implement their database products. And that lent Java a level of credibility that they couldn't otherwise have had. So Oracle is a much bigger company than Sun Microsystems, and their decision to adopt this kind of was a signal to the world that Java is going to be a very valuable technology for writing computer programs. What else did Gosling do when he came up with this Java language? He built in some documentation tools and internationalization tools into the language so that you can write code that is kind of self-documenting and is fairly easy to modify so that it will work differently in different cultures. So if you want to display a dollar sign in the United States and a yen sign in Japan, he took that into consideration from the very beginning. The other thing that's very important to us about Java right now is that it's easy to learn, and it's easy to read other people's code who are writing Java in a kind of a standard, consistent way following the conventions. Gosling was a C++ programmer, and he learned things that were wrong with C++ over a period of about 15 years. And he took out the things from C++ that were costly. Not because they didn't work, but because they were complicated. And programmers like this. They can write code quickly, and they can look at other people's code and understand what it's doing much more quickly than the competing languages, in particular C++. So if you know any C++, these two things would be important to you. There are no pointers in Java, and Java is an object-oriented language that uses single inheritance. If those don't mean anything to you, they will before we're done. So this is kind of the introduction that you can kind of understand, and maybe we'll come back and look at this near the end of the semester. Okay, in each of these segments we're going to have a summary of what we covered in the segment, and in this one we looked at syntax for writing a program in Java. This is where do all the braces go, and the parentheses and the double quotes and so on, and understanding how to recognize syntax errors as we type in Eclipse. So Eclipse shows you the errors as you go along, which it's maybe annoying at first, but it turns out to be really a big time saver for you. We looked at the history of Java, why it's popular, and its survival through radical changes in computing. I'm not sure that I made that point well enough. What are the radical changes in computing that we've seen in the last dozen or 15 years? We've gone from everything executing on a machine to almost everything executing in the presence of a network. So the internet has changed everything. There isn't going to be any programming anymore that doesn't include something to do with the network. And the display portion of the applications, or the front end, the user interface, is now often presented through a web browser, and the back end, or the business part of the software, is running on a web server. So these are big paradigm shifts, and Java was such a strongly engineered language that it survived these, and it's still popular, and it's been popular through the last dozen years. Okay, so here's the reminder, just in case you didn't really do it. You must get a simple Java program to run, and all of the subsequent work that we do will depend on your ability to experiment in Eclipse with the concepts as they're introduced. Okay, I hope we're going so far so good, and I will see you in the next segment.